Today we are going to discuss about the transportation problem. What is the relation between the transportation problem and the LPP? See, here various warehouses, here 4 warehouses, 3 stores. From this which warehouse, which store, if you transpose, the cost will be reduced. This is the objective of the transportation problem. Can you recall that? From which warehouses, there is 4 warehouses. Warehouse 1 availability 6, warehouse 2 availability 8, warehouse 3 availability 12, warehouse 4 availability 4. Store 1 requirement is BJ is the requirement. S2 store 2 is 10 requirement. S3 store requirement is 12. So if this requirement and the availability should be equal, total should be equal, then only we can proceed further. That is called the balanced transportation problem. Okay. So how you find out the optimal solution? I will explain first. The procedure wise, see, first that all the each element xij is greater than or equal to 0. Therefore, the total availability is equal to the total requirement. Therefore, the given transportation problem is that balanced. How you allocate? Why this is called northwest corner rule? Because we are starting from this northwest corner of this tabular form. So, from the 1, 1 northwest, you have to find out the minimization of the availability and the requirement 6, 8. That minimum equal to 6, you have to allocate that 6 value, that remaining is 2. Then you have to minimization of the minimum of the 2, 8 equal to, that allocation should be made in the second row and the first column. Therefore, as consequent, column 1 is exhausted. Then you have to find out the minimization of 10, 6 is allocated in the cell 2, 2. Consequently, ratio row 2 is exhausted. Then you have to find next, after exhausted, the remaining minimum of 4, 12, that is equal to 4, allotted in third row, second column. Therefore, column 2 is exhausted. Then finally, minimum of 2, 8, 12, 8, 8 is allotted in cell number 3, 3, row 3 is allotted. Then almost remaining fourth cell, fourth column is allotted. Therefore, third row is also exhausted. All the rows and the columns are exhausted. Then you have to find out the total cost. How to find out the total cost? That allocation x1 and row 1, row column allocation is 5. The corresponding cost is that is equal to 6. Similarly, x21 2. The total allocation is cost is multiplied. X22 second row, second column, that is 6. X32 4, X33 8. So you multiply along with the cost, the total cost equal to 190. This is the procedure for the northwest corner rule. In the northwest corner rule, see here I am allocating in the warehouse 1, store 1, 6 is allocated. How I am allocating? From the minimum of 6, 8, I am allocating 6. In the remaining is 2. So, in the 6 is exhausted, row 1 is exhausted, that remaining is 2. In the 2, 8, that minimum of 2 is allocated, then the column is exhausted. That remaining here, next you have the remaining coefficients we are considered. 10, 6, you have to allocate minimum 6, the minimum 6 remaining 4, then that row 2 is exhausted. Then from this 4, 12, that minimum of 4 is allocated in the third row and the second column. That allocation is 4. That therefore this column is exhausted. Then remaining 12, 12. Then 8 is allocated. The remaining is 4. That 4 is allocated in the fourth column, row 4 and column 3 you allocated. All the rows and the columns are exhausted. So from this allocated, corresponding cost is multiplied. You have to find out the total cost. So this is how you have to formulate the mathematical formulation of the transportation problem. That is how to find out the feasible solution. If the availability and the requirement, that availability from the I equal to 1 to m, j equal to 1 to n, bi, if equal, that then only that is called the feasible solution. The feasible solution, this is the mathematical formulation, that is minimize z equal to, this is a cost associated xi. You have to find out the total cost.
then they subject to the restrictions, that is availability and as well as the requirement, availability and the requirement from the all sources should be equal. Then the allocation should be made from this warehouse to the store. You have to find out the optimal solution, optimal minimize the transportation cost. This is the objective of the transportation cost. Very first method is northwest corner. Is there any doubt? Thank you.